You guys, this is page 205, question 6. We're still in the first activity, and there's a lot to do in that activity. So with this one, it says, make conjectures about vertical angles, alternate interior angles, corresponding angles, and points on the perpendicular bisector of a line segment in order to write theorems. That's one of the learning goals. Here's the other one. Identify line segments, lines, and angles associated with the interior and exterior of a circle. Well, draw a line through two of your labeled points on circle O to form a secant and a chord. They can't be diameters, though. Here's the thing. I've already put so much down on this picture that I don't want to add more to it. I want to bring this picture over to the other side. You could use tracing paper and trace it, but perhaps I just want to make sure that it's clear. You can also use a compass to capture the radius of the circle, being very precise. These compasses are super dope because they're able to like make little adjustments. So capturing the center and edge of the circle, that'll form the radius. And then move that over to this space. And I'm going to draw my circle up here. Draw the circle. Man, this is like a $4 buy from a nearby store. You might have heard of it before. It's called Walmart. If you are looking to make your life easier in this class, you should probably think about getting one. I'll try to provide what I have, but sometimes the best I can offer is that super expensive circle creation device. It's a joke. Okay, draw a line through two of your label points. So here's circle O, label O, to form a secant. Remember, secants are lines and chords are segments. So let's go something like this. Secant line. All right, it's not a diameter because it doesn't go through the middle. It's a secant line because it has arrows it keeps on going for forever. But a chord stops and is the place where the secant line and the circle cross. It doesn't say what to label them. I'm going to label them A and C. All right. Use a protractor to measure the angles of the triangle I don't know what that is. I mean, I know what a triangle is. Don't get me wrong. Like, oh my gosh. He said it. You heard it here. Oh, I follow. Okay, I do need to go back over to here. So thanks for playing, but no thanks. Okay, let's go back over to here. They do. I had to review what I'm supposed to do here. So I'm going to actually draw a secant line through BM. Kaboom. And if only I had another highlight color. I've got like all these greens and like yellows and pinks. Let me go see what I can find. Give me 2 seconds. 1001. 1002. It's too long. When in doubt, Crayola. All right, here's my secant line. Oh, that's so like too dark of a color. All right, whoever's book this is, you're welcome. It's got to have arrows on the ends, so make sure that those are visible. And then it says use a protractor to measure the angles and side lengths. So I'm using page 205 over here, but I'm going to use this space. Okay, center of the protractor goes on M. The black line of the protractor I'm going to put on the diameter of the circle. And then if I look at this secant line, if I extend it, I mean, I need to extend it super, like so much longer. Careful measuring. There we go. Okay, I needed to draw the line longer because it wasn't actually touching the edge of the protractor. Reset that. Here we go. Circle goes on M. Black line of the protractor goes through D. Oh, I'm so good. Look at that. 10, 20, 30, 40, 50, 40, 50, 45. This is a 45-degree angle. And I'm going to put that over here as angle. I guess since M is the middle, it'd be OMB. The measure of the angle is 45 degrees. Do you want to take a guess as to what the measure of angle MBO is? Hint, that's MBO, M to B to O, that's that angle. It's also 45 degrees. Okay, common answer in geometry class is how many degrees, what's the measure of the degrees that form an angle? 180. So if you have 45 and 45 together, that's 90. That means that the measure of angle MOB, we already know that. We already know that the measure of angle MOB, it's 90. So then this is already a 90-degree angle. Oh, if two of the angles are the same in a triangle, if two of the angles are the same, you've created something called an isosceles triangle. More specifically, it also, because of the 90-degree angle, it's an isosceles, hope you have a pencil, not a pen, right triangle. Literally the right angle is what makes it a right triangle. And then these 2 degrees being the same is what makes it isosceles. All right, compare your circle diagrams to your classmates' diagrams. Did you know everyone create the same triangle? Yeah. All right, the same type of triangle? Yes. Do you think that all circles are similar? You know what? Actually, all circles are similar. This is totally true. Similar, yes, because similar means that you can make circles be bigger and smaller in size. And when you do that, creating a circle that's bigger or smaller in size, you're still creating a circle. So all circles are similar. Congruent? No. Not congruent, because maybe your circle that you created was, you know, that big, and then someone else's circle was teeny tiny, that big, and someone else's was, you know, this is how you make circles bigger. You just widen out the span there. Different sizes, not congruent. Congruent means they have to be the same size. Okay, last of all, recall that a conjecture in mathematics is often in the form of if P, that's the hypothesis, then Q, that's the conclusion. Don't stumble over that. Hypothesis, conclusion. So in mathematics, if we make a hypothesis, we'll say, ooh, if 2 sides of the triangle are the same, or if 2 base angles of the triangle are the same, then it's an isosceles triangle. Hear the if-then? Listen for it. Mathematicians write and revise conjectures. So this is a proper guess. Okay, a proper guess, a conjecture. It's proper because of how we created it, right? So that they have a clear mathematical statement they can test and share with others to test. We're going to make a conjecture in mathematics. You must first anticipate that some relationship might exist, or some statement might be true. That's the Q part, given one or more assumptions. P, hypothesis, aka assumptions. All right, what conjecture can you make about this triangle? If this triangle is isosceles, so this triangle, let's name it. Let's go back all the way up to here, all the way back up to here. This is the triangle I'm talking about. B, M, and O. B, M, O. This triangle is a triangle I'm talking about. So I'm going to name it in my statement. If this triangle, line it up. Here we go. Triangle BMO is isosceles. Right? That's the case. If this triangle is isosceles, what does that tell us? It tells us that the 2 base angles are congruent. There we go. Longer video for page 5. A lot happened in this one. Page 205, I mean. We're going to take a look at page 206. Let me do a little quick check forward. That's activity 2. Join me for activity 2 page. Thanks for watching and going through activity 1 with me. Activity 2 next. Bye.